Our environment consists more and more of man-made products. Every product relates to and affects the environment. To evaluate the environmental effect of a product, we have to consider that product's whole life cycle from the cradle to the grave. The life cycle consists of raw material extraction, production phases, use, reuse, and disposal. Every single product has its place among others. In fact, a product is often a set of combined products. If we want to make environmentally sound products, what can be done to help designers and decision makers? Lifecycle assessment is a tool for evaluating the environmental effects of a product during its life cycle. LCA gives valuable information for decision-making in management and product design.
Life cycle analysis is actually not very complicated. You could say that life cycle analysis is actually setting boundaries, taking material and energy in, measuring energy usage, materials out, and emissions out.
To get the right answers, we have to ask the right questions. What do we want to achieve with an LCA?
In the late 80s, we got to know about life cycle assessments, and they immediately aroused our interest because this concept matched our thinking. You shouldn't just look at isolated product properties, but have a holistic view. Look at the whole production chain and improve where the environmental benefit is the biggest. When setting up an LCA, it is very important to decide what will be the use of the results. The way you express them, what you exclude, what you include, that will vary. It's extremely important to do it in a transparent way, that anybody can come in and see how it was done, how the selections were made, and how the calculations were made, the quality of the basic data and so on. In our case, we wanted to use it for product development. So we chose the system boundaries for that need. We had new products in the pipeline coming or being developed for the market. So we could immediately make use of the benefits of this tool. I think initially we thought that it would be the product development people themselves who would carry out the LCAs. We soon realized that we have to have specialists who have enough experience of the issues at stake. The people who took part in this exercise were quite excited, actually, over the process, because there were people from the refinery and these development people working together in very interactive sessions, and everybody learned a lot about the different units, how they perform, and how they individually affect the eco-balance of the combined product coming out.
The precise goals of the LCA should be defined through cooperation between management, LCA experts, and people on the functional level. The data collection and inventory stages are dependent on the goals set earlier.
The chain that we looked at included crude oil production, refining, cracking, and the actual polymerization. When you look at the final plastic product, it is very difficult to trace the material back to a specific crude oil source. And that is also why the European plastics industry chose to provide average values for the different polymers. Our people had to go into the plants, into the operating rooms to collect actual data from reports, gather them, and try to accumulate them on an annual basis. When allocating energy and material to the different products, we chose to do it on a mass basis because we found that that was the most representative way of doing it. The work was much bigger, took much longer time, much more effort than we ever had anticipated. We used some 2 or 3 years just to collect basic data because some of the parameters we even had to measure at the different plants.